Geometry, Chapter 10 review. You are standing at point B. Point B is 16 feet from the center of the circular water storage tank and 15 feet from point A. Find the radius of the tank. Basically, you could read the whole problem, but this is a right triangle because the tangent and the radius will form a right angle. So we have the radius squared plus 15 squared equals 16 squared. Radius squared is radius squared. 15 squared is 225. 16 squared is 256. 256 minus 225 is 31. The square root of 31 is roughly 5.567764 or 5.6. Next problem. Find the measure of DB, of arc DBC in circle P. It looks like DB is a diameter, but I don't know for sure. So if this is 58 degrees, that is also 58 degrees. So if the entire circle would be 360 degrees, minus 58 is 244. This and this are congruent. So 244 divided by 2 is 122. So arc AB is 122. So 58 plus 122 plus 58. So 122 plus 58 plus 58 is 238. Just curious here, let's see, 122 plus 58 is 180. So that is a diameter, even though I wasn't sure whether it was or wasn't. Okay, problems 3 and 4. Q, T, and RW are both diameters. They want me to find QW. Well, if this is 40, that's 40. I could start filling all of these in, but I know that this is 180. I also know that this is 180. I just want QW, so 180 minus 40 is 140. So arc QW is 140 degrees. For the next problem, this entire arc, it's a major arc, it's 270 degrees. So if I start at 360, I subtract 270, and I subtract 45. This is also 45. So if this chord intercepts an arc that's 45 degrees, then if this arc is 45 degrees, the chord that intercepts it is going to be the same as the other one. So the answer is 6. We did the proof in class, and as I said in class, I purposely picked a proof that I think went a little off track because my concern is that you get something on EOC that's weird or not well written and you don't know what to do with it. Because a lot of these practice things that I see for the EOC are not well written. So for the given, I'm just going to fill in what they gave me. Okay, DA is congruent to DB, which is congruent to DC. I also know that angle ADB is congruent to angle BDC. You also could have said angle 1 is congruent to angle 2. You could have said ADB is congruent to CDB because all of the sides are congruent. So now I know that these angles are congruent. Now, realistically, you don't need this part of the proof. If the angles are congruent, then you could say, let me type this in here so I can type so you can actually see exactly what I would say. You could say from the angles, that angles, actually we should say central angles on the same circle that have the same measure will have congruent arcs, intercepted arcs. So basically central angles on the same circle that are, or actually I'm going to put this even here, congruent central angles on the same circle will have the same congruent intercepted arcs. So I don't even need that part. No, I'm typing a lot here. So as I said, I don't even need this, but sometimes on a proof, you will get extra things that you don't need. So let's say I was doing this proof and I started to say, oh, I have two sides, an angle. I think I could make congruent triangles here. I can draw a line from A to B, and B to C. And the reason is, for number 5 that I can draw it, is you can draw one line through any 2 points. Now that I drew a line, I actually made 2 triangles, and they are congruent by side, angle, side. If they are congruent by side, angle, side, then these marks here, these sides that I drew, are congruent by C, P, C, T, C. As I said, there's extra information in this proof that you do not need, but I was concerned that you get a question on the EOC that asks things or includes things that you don't need in the proof. You can still come up with the statement for them. Number 6, the measure of PSQ, this angle, is 3y minus 15. And the measure of PRQ is 2y plus 25. Since they intercept the same arc and they're both inscribed angles, the measure of those angles is going to be congruent. So 3y minus 15 is equal to 2y plus 25. Subtract 2y on both sides to get y equals, and add 15 to both sides. So 25 plus 15 is 40. But 40 is not the answer because they want the whole angle. So 3 times 40 is 120. 120 minus 15 is 105. I'm going to check that over here. 40 times 2 is 80 plus 25 is 105. So the correct answer is C. Measure of IED is 116. So that's 116. Find J, and at JFG is 100. Find the measure of each unknown angle. Well, angle 2 is going to be a linear pair with 116. So 180 minus 116 is 64. So it cannot be C and it cannot be D. Now, 2 and 4 are going to be supplementary. So obviously 180 minus 64 is going to be 116. We just went through that. So it's answer A. Make sure that still works. Angle 1 would be 80 and angle 3 would be 100. So the correct answer is A. For number 8, find the measure of arc BC and angle D. BC is an arc intercepted by the inscribed angle BAD. The inscribed angle is 40 degrees. Remember, if you have an inscribed angle, it's equal to 1/2 the arc. Or the arc is equal to 2 times the inscribed angle. So the arc is 80 degrees. Now, BDC is an inscribed angle. If the arc is 80 degrees, the inscribed angle is 40. So minor arc BC is 80 degrees. The angle D is 40 degrees. And then for number 9, given that DAB and DCB are right angles. So we had a theorem or a rule that we learned that if a triangle is inscribed in a circle and its angle is 90 degrees, then its hypotenuse is the diameter. So we also learned that DBC, that angle there, is 42 degrees. So that angle creates this inscribed angle, which gives this arc here a measure of 2 times the angle. So that's 84. And this part is 180 degrees because it's a semicircle. So they asked for CAB. Remember, that's 84, that's 180. 180 plus 84 is 264. Problem number 10, I told you didn't have to worry about C and D. Okay, this is a regular pentagon. Could actually break this into 5 triangles. All of these are going to have the same measure. They all add up to a circle. So 360 divided by 5, each central angle is 72 degrees. And if each central angle is 72 degrees, these are all radii, so they're all congruent, meaning these all make isosceles triangles. The vertex angle is 72 degrees. So 180 minus 72 is 108. Divided by 2 is 54. So this is an isosceles triangles with a 72 degrees vertex angle and 2 base angles, each of 54 degrees. In the diagram here, BD, arc BD, is 114 degrees. And arc D to F is 94. And F to H is 136. And H to B is 16. Find FPD. So I want this angle right here. So since I have 2 secants that intersect outside of the circle, they create 2 arcs. The formula is 1/2 of the difference of the intercepted arcs equals the angle. So 94 minus 16 is 78. And 1/2 of 78 is 39. So A is 39. On the next problem, we again have two secants that intersect outside of the circle. AB is 82. In this case, they told me the measure of the angle. They want me to find the measure of this other arc. So 1/2 of the difference of the intercepted arcs. One arc is 82 degrees. The other arc I don't know. But 1/2 of whatever that number is going to equal 30. If I multiply, I'll write that in a minute. That was written in from class earlier today. I'll go back over that. But 82 minus x equals 60. When I subtract 82 from both sides, I get negative x equals negative 22. So that means that x, or the measure of CD, is 22. I think the answer key says 26. It's because when I made the problem, I changed the number here. So it is 22. And on number 13, the drawing is missing. It should be a circle with chords that intersect and create two angles. These are not drawn to scale, but that's 62, and that's 20. In this case, since they intersect inside the circle, we add them together. 62 plus 20 is 82, and half of that is 41. From problem number 13, and I don't read all these problems always, you can pause it and read it. And basically, we have a hummingbird. And the hummingbird is flying towards a tree, and it can see this part of the tree because these are its sight lines. And its sight lines are tangents, and they're going to intersect a radius at a 90-degree angle. So we have two right triangles here, and as soon as you see right triangles, you're thinking Pythagorean theorem, or you're thinking trigonometry. And that's exactly what you should be thinking, because if they want us to find this blue arc, if we find the measure of these, I'm going to color them in green, angles, they're each going to be equal. And then we will have that total arc. So when I look at the numbers that I'm given a measurement of 6, and I'm going to give a measurement of 31. 31 is the hypotenuse, because that's opposite the 90-degree angle. And when I'm dealing with this green angle here, the 6 is actually the adjacent side to that angle. So if you remember TOA, when we have adjacent and hypotenuse, we're using cosine. So the first thing I need to do, I'm going to actually use this calculator because it's going to have the ability for me to do inverse tangent on it. So 6 divided by 31 is that number. And since I'm dealing with cosine, I want the inverse, the second degree inverse cosine. So basically what I'm saying here is I have to remember that number, 78.84. If I have an angle that has a measurement of 6 divided by 31, that equates to an angle of 78.84 degrees. And then, since I have two of those right next to each other to make this total arc, 78.84 times 2 is 157.68. Now, problem number 15 deals with the measure of angle A is 30 degrees, and they tell me that DE is 50. And I looked at this a bunch of different ways. Thought I was going to have to write a system. Because I did recognize that there's two intercepted arcs here. That these tangent lines intercept these two arcs, and the two arcs are going to equal 360 degrees. So I went ahead and I decided I'm going to call this arc X, and I picked that really because that's also the arc that is intercepted by angle BFG, which is what I eventually want to find. So if that is X, and the whole thing is going to be 360, then the red arc is going to be 360 minus x. That's going to represent that measurement. This black X represents that measurement. You remember, if you have two arcs that are intercepted by lines, or tangents, tangent rays actually, and intersect at a point outside of the circle, the formula is you're going to take the difference of two arcs, divide it in half, and that's going to equal 30. And I wasn't sure this was going to work, but I was like, wait, I do have this like weird equation that has just x's. So 1/2 of 360 minus x is 360 minus 2x equals 30. So half of this would be the same as multiplying by this side by 2, so 360 minus 2x equals 60. When I subtract 360 from both sides, I get negative 2x equals negative 300. So x has to equal 150. So now I have that. That's 150. I'm going to erase this work here. I'm going to erase this stuff. Go back to the beginning. They told me that DE was 50 degrees. So hopefully what you can now see is I have two chords. They intersected a point inside the circle. Those angles, DFG, correct, is two arcs. Remember the formula for when they're created by chords that intersect inside the circle? You add the intercepted arcs together and take a half of it. So 150 plus 50 is 200, and 1/2 of 200 is 100. So BFG is 100 degrees. For problem number 16, okay, we have some information. BC is 18, and DC is 22, okay? And they want me to find the diameter of the circle. So basically that's AB. That is the internal part. I'm going to call that X. So since I have a tangent portion, that's 22 squared equals the external segment times the entire length of the secant. And the entire length of the secant is actually X plus 18. So 22 squared equals 484 equals 18x, and then 18 times 18 is 324. Subtract 324 from both sides. 484 minus 324 is 160 equals 18x. And 160 divided by 18 is 8.888888, which rounds to 8.9. That's the answer for B. 17, I had to make this a little bit larger, and I can see that now I have two secants with an external length and a internal length. So on the first one here, that's an 8. So the external segment is 8. The whole segment here is X. That's going to equal 9 times the entire length. And 9 plus 15 is 24. So 8x equals 9 times 24 is 216. And 216 divided by 8, x equals 27. For number 18, same type of problem. although it is difficult to see what that number says. I think it says 10, in which case we would have 6 times the entire length, which is x, equals 8 times the entire length, which is 18. 8 times 18 equals 144, divided by 6, x is 24. So here we go for this problem. Diagrams AD and AB, AD and AB are tangent to the circle. AC bisects angle DAB. Prove that AC is perpendicular to DB. So we're given a few givens here, and you can see we broke them up. So AD and AB are tangent segments from the same point. That's given. So that means that AD and AB are congruent. Tangent segments that share the same endpoint are congruent. Then we're also told that AC bisects DAB. We were given that. So DAF is congruent to BAF. And that would be, type this in here, okay, definition of an angle bisector. Okay. So for the next part, we're missing another step, and step 6 is CPCTC. So this is one, as I said, I don't love this because I feel like we've missed a step here. Normally, we would have another step that said that AF is congruent to AF from the reflexive property of congruence. But as I said, when I look at these that are done by some other sources, sometimes the things that are very obvious, like AF is equal to itself, are kind of left out. So I'm going to now say that triangle ADF is congruent to triangle ABF. And I say that because of side angle side. From there, they talk about something else that is congruent, CPCTC. But I need to figure out what, there's a lot here that's congruent, so I need to figure out what they're exactly talking about. So I'm going to erase some of this stuff here, just so that I can better look at my triangle and see what they talk about. First, they talk about angle AFD, okay, and AFB form a linear pair. And really, I can just see that. So whenever I can see something, I would say definition of a linear pair. Okay? And AFD and AFB are right angles. So we're talking about AFD and AFB twice here, which means here I could say that angle AFD is congruent to angle AFB from corresponding parts that congruent triangles are congruent. There's lots of things I can say, but I can look at the proof and see that they keep talking about these. So if they're congruent and they form a linear pair, then they must be right angles. Okay? So form a linear pair, they're right angles. If they're congruent and they form a linear pair, they must be right angles. That is the definition of right angles. So AC and DB must be perpendicular because basically two lines are perpendicular if and only if they form right triangles. They intersect and form right triangles. I think you could probably have also just used definition of perpendicular there. If you have two right angles, two lines are formed by right angles, then they're perpendicular. Once again, this is going to be from a list of a bank, so you will have choices there. Number 20, write a standard equation of a circle. So we have to remember that default, x minus x1, quantity squared, plus quantity y minus y1, quantity squared equals radius squared. So x minus a -3 is x plus 3 squared, plus y minus -4 is y plus 4 squared. The radius is 6, so that equals 36. And that is your equation in standard form. For number 22, a small messenger company can deliver only in a small part of the city. Write an equation for the boundary where the company delivers and find its radius. So this is a little weird, but basically they're saying 1, 2, 3, 4, 5, 2. So they're centered at a circle that overlays on a map at 0.52. 1, 2, 3, 4, 5. The radius is 5. You can go 5 to the east, 5 to the west, 5 north, 5 south, and 5 at any angle in between. So x minus 5 quantity squared plus y minus 2 quantity squared equals 25. Okay? For number 22, the center of the circle is going to be at 4, -3. Okay? So 4, -3. 1, 2, 3, 4, 1, 2. This radius squared is 25, so the radius is 5. So 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down. Just kind of sketch this out. Doesn't have to be perfect. But there you go. That is your sketch. Label the coordinates of the center and the intercepts. At this point, I'm just concerned about you being able to do the center.